Raymond Hyde studied the dynamics of fluids. He achieved important insights into meteorology and planetary atmospheres. He studied also the Earth's magnetic field, showing how it was generated by convective motions in its electrically conducting liquid core, and how similar processes could operate in the Sun and other planets. He achieved these insights by a mixture of mathematical modeling and ingenious laboratory experiments. Raymond was born in 1929 in a coal mining village in Yorkshire. He attended the local grammar school and then gained a scholarship to the University of Manchester. Here he was lucky to be mentored by the great physicist Patrick Blackett. Blackett had become interested in understanding why the Earth, the Sun, and other cosmic bodies had magnetic fields, a mystery at that time. He made a radical conjecture that there was a new fundamental law whereby gravitating bodies would get magnetized if they were spinning. This simple law was testable because it would have implied that deep inside the Earth, the field would have been weaker. Blackett decided to test this prediction by making measurements down a mine shaft, and Raymond, an undergraduate, went along as a research assistant. The magnetic field deep down turned out to be stronger, refuting the theory. This introduction to science's methodology, helping an eminent scientist refute his own theory, had a formative impact on Raymond. He decided for his PhD to explore more complicated ways in which rotating objects get magnetized. And he became a pioneer of the now accepted theory that in a conducting fluid, like the Earth's molten interior or the ionized gas that the Sun is made of, convective motions could generate magnetic fields by a kind of dynamo action. His PhD thesis was a classic. He tried to simulate convective motions in a gravitating fluid by a very simple experiment. It involved two vertical glass cylinders, one inside the other. Water was placed in the annulus between them. The cylinders were spun so that centrifugal force mimicked gravity, and the outer cylinder was kept hot and the inner one cold. This radial temperature gradient would induce convection, as inside the Earth or a star. As the spin rate increased, he found a transition from regular patterns to periodic fluctuations, which he called vacillations, and ultimately to chaotic behavior. These experiments were motivated by attempts to understand the Earth's interior, but Raymond realized they were relevant to atmospheric circulation, and their ramifications motivated much of his subsequent research. He spent a postdoctoral year working with Chandrasekhar in Chicago, followed by 3 years national service back in the UK, and then a lectureship at Newcastle. While there, he further developed models of terrestrial and planetary atmospheres. And he found a fluid mechanical explanation of something which had long fascinated him, the stable, long-lived feature on Jupiter known as the Great Red Spot. Raymond moved to the USA in 1961 as a professor at MIT, but after 6 years he came back to the British Meteorological Office. There he headed a geophysical fluid dynamics laboratory where he could do more elaborate experiments. For instance, repeating his PhD experiment, but with an electrolyte instead of water to study magnetic effects. He also explored how motions in the Earth's liquid core distorted the core-mantle interface and the consequential changes in the Earth's rotation and the length of the day. He and his group later moved to Oxford to work at what later became the Hooke Institute, and he became a fellow at Jesus College. After he had officially retired in 1992, he took up various visiting positions before settling in the maths department at Imperial College London. By this time, computers had advanced to the stage that numerical experiments could supplement those on real fluids. And he showed how the magnetic fields in small bodies, for instance, in the solar system, could be generated by high-velocity impacts. Raymond's scientific career was celebrated by a Festschrift on his 80th birthday in 2009. In his last years, he became frail and moved with his wife, Anne, to a care home where both passed away within a few months of each other when he was 87 years old. Raymond became a Fellow of the Royal Society in 1971 and received a CBE from the UK government in 1990, as well as other awards. He served unusually as president of both the Royal Astronomical Society and the Royal Meteorological Society. He was elected to this academy in 1996. He attended several of our meetings, speaking at 4 of them, always with clarity, deriving important conclusions about nature from simple models. He was a wonderful companion and a mentor to generations of younger scientists. May he rest in peace.